Find the average rate of change of g of x equals x squared on the intervals from 0 to 1 and 2 to 3. Let's start by looking at the interval from 0 to 1. The average rate of change can be calculated by taking the difference in the function values, in this case f of 1 minus f of 0, dividing by the difference in the x values of the endpoints of the interval, in this case 1 minus 0. F of 1 is just going to be 1 squared, and f of 0 is 0 squared. And in the denominator, 1 minus 0 is 1. Just quick calculations. 1 squared is 1, 0 squared is 0, 1 minus 0 is 1, and 1 divided by 1 is 1. So the average rate of change of this function from 0 to 1 is 1. Next, let's look at the interval from 2 to 3. Here, to calculate the average rate of change, we're going to take f of 3 minus f of 2 over 3 minus 2. It's such an easy function, I even feel silly writing 3 squared and 2 squared. We know here 3 squared is 9, 2 squared is 4, 3 minus 2 is 1, and 9 minus 4 is 5. 5 divided by 1 is 5. So in this case, the average rate of change is 5. Notice that the average rates of change here are not the same. This is because we have a function that's not linear. So the rate of change is going to be changing as we look at different x values. In fact, the average rate of change is increasing because we know the graph g of x equals x squared is getting steeper as we move to the right on the right-hand side of the graph. So at first, we're going to have a slope of 1 if we look at the secant line between 0 and 1. And then as we move further and further to the right, we've got larger and larger slopes. In fact, if we were to look at any interval that's further to the right of 2, 3, we're going to have a higher rate of change because that graph is getting steeper and steeper and steeper.